In this recording, I want to talk about interpreting information about graphs from a table of values. So let's look at this table that I have. I'm really looking at two separate equations, and those two equations, y sub 1 and y sub 2, they're going to have the same x values associated with them. So, for example, I'm going to pick some x values. These x values are just random numbers that I'm using. -3, -2, -1, 0, 1, 2, and 3. So these are just x values that I'm picking. And suppose whatever this first equation, equation 1, suppose whatever it looked like, if I plugged a -3 in for the x and went through the calculations, it gave me a +9 for the corresponding y. And suppose that I plugged a -3 into the other equation and it gave me a 5. Likewise, if I plug a -2 into my y sub 1, it gives me a 4. And if I plug that same value of x of -2 into my second y, it gave me a 4. Now, you'll see where these numbers are coming from in just a little while, but right now we're just saying that we plug these numbers in, and whatever this equation looks like and whatever this equation looks like, once we go through the math, these will be the corresponding y values that we get from the x's that we plug in. So -1 would give me a 1 for the first equation, and it would give me a 3 for the second one. For the first one, if I plug in a 0, I get a 0. In the second one, I get a 2. If I plug x equals 1 into y sub 1, I get a 1 and another 1. And for x is 2, y sub 1 gives me 4, y sub 2 gives me a 0. And if I plug a 3 into each one of them, I get a 9 and a -1. Now, let's just talk about this. We could actually plot these points in the rectangular coordinate system, but let's see if we can get some information about these graphs, about these equations, just by looking at the numbers that we have. So I'm going to give you several possible equations for this y sub 2. So y sub 2 could be x plus 8, or it could be x minus 2, or it could be -x plus 2, or it could be 1 minus 2x. Now, only one of these is correct. If you have values and you have equations and you want to see which equation is actually the correct equation for the information that you're given, what you have to do is substitute your values of x and y into the equation and see which ones give you a true statement. So what we're going to do is we're going to use this table to determine which equation corresponds to y sub 2. So how do we do that? Let's look at our first equation. Y sub 2 equals x plus 8. So we're only looking at this this first column, y sub 2. And these are all of the y values. So let's start with the 5. If my y sub 2 is 5, the x value that we used was -3. So y sub 2 is 5 and x is -3. We bring down our 8. The question is this a true statement? 5 equals -3 plus 8. 5 is equal to 5. So that's a true statement, but that's not enough information to tell us if this is really the equation. We need to pick some other values to see if we get a true statement. So let's look at another value. Let's suppose we plug in a 4 for our y sub 2. And our x for that 4 is -2. 4 equals -2 plus 8. But notice what happens when we go through the math on this one. We get 4 is not equal to 6. So even though this first one was true, this second one was false. What this tells me is that this equation is not the equation that represents the values that we have for y sub 2. So this is not the equation. Let's look at the second one. We go back, we plug in our 5, and we plug in our -3. 5 equals -3 minus 2. We can already see we have a problem here. -3 minus 2 is -5. And we know that 5 is not equal to -5. There's no need for us to try any other values because we got a false statement as soon as we started. So let's move to the next equation. Y sub 2 equals -x plus 2. And we're going to plug our 5 in again, and for our x we're going to plug in -3. 5 equals the negative of -3 plus 2. That's a double negative, so minus a negative is positive. So 5 is equal to 3 plus 2. 5 is equal to 5. All right, so we got a true statement. But just like we did on this first one, we need to check to see if we get another true statement. So we're going to plug in the 4 and the -2 this time. 4 equals minus a -2 plus 2. That's a double negative, so we get a positive 2. 4 is equal to 2 plus 2. 4 is equal to 4. So that's true as well. And what you'll find is if you continue to go through this, all of these will give you a true statement. And that tells me that this equation is the equation that represents the set of values that we have for x and y sub 2. Now, since we already found this as our equation, there's really no need to even check this last one. So we'll just skip that one. All right, let's look at y sub 1 and some possible equations for y sub 1. Y sub 1 equals -3x. Y sub 1 equals x squared. Y sub 1 equals -x squared. Y sub 1 equals 2 minus x. For this, you'll actually go through the same process, but this time you'll use these red values for your y's and then the same x's. And as you go through it, what you'll find out is that this equation is actually the correct one. Y sub 1 equals x squared. So if you square a -3, you get a positive 9. If you square a -2, you get 4. If you square -1, you get 1. Squaring 0 gives you 0. Squaring 1, and so forth. So without going through all of the steps, this is the equation that will satisfy all of your points here. So if you want to know if an equation represents a set of ordered pair, all you have to do is substitute your x and y values into the equation. If it gives you a true statement, then that particular set of points is a representation of that equation. What else can we figure out about the graphs of these two equations, y sub 1 and y sub 2, just by looking at the points? All right, well, let's talk about the origin. Do either of the graphs pass through the origin? Well, first of all, you have to know what the origin is. Remember, on the XY coordinate system, our origin is right here in the middle. So that's the point 0, 0. So the question is, do either of the graphs pass through the point 0, 0? So we need to look at y sub 1 and y sub 2 and see if one of them or both of them have a point where the x is 0 and the y is 0. So if we look at our x values, so here for y sub 1, when x is 0, the y is 0. So looking at this, y sub 1 is the only one that passes through the origin. Y sub 2 does not have a point where the x and y are both 0 at the same time. Where does the graph of y sub 2 cross the y-axis? Now remember, your y-axis, if a graph crosses the y-axis, that means that that point is actually a y-intercept. And what do we know about all y-intercepts? The x value is equal to 0. So the question is there a point on the graph of y sub 2 that has an x value of 0? All right, well, actually, we know it does because the question is asked, where does the graph cross the y-axis? So it crosses the y-axis where the x is equal to 0. So our x is equal to 0. And if we look at our y sub 2, the y value is 2. So y sub 2 crosses the y-axis at the point 0, 2. Where does the graph of y sub 2 cross the x-axis? So remember, your x-axis is your x-intercept. For all x-intercepts, the y value is 0. So what we need to do is look at the graph of y sub 2, or look at the points for y sub 2, and wherever the y is 0, we need to know the corresponding x value, and that is where the graph will cross the x-axis. So if we look at our y sub 2 and the y is 0 here when x is positive 2. So this graph crosses the x-axis at the point 2, 0. At what points do the graph of y sub 1 and y sub 2 intersect each other? If two lines intersect each other at a given point, then that means that that point is exactly the same for both of those lines, for both of those equations. So what I'm looking for are any points that are exactly the same for each one of the equations. So if we look at this, when x is negative 3, we have different y's. When x is negative 2, we actually have the same y. So at negative 2, 4, negative 2, 4 is a point that both of these graphs pass through, because when x is negative 2, the y is positive 4. Let's see if there's another point here. When x is negative 1, the y's are different. When x is 0, the y's are different. When x is 1, the y's are the same. So here's another point. 1, 1 is a point that both of them have that are exactly the same. When x is 2, they have different y's. When x is 3, they have different y's. So negative 2, 4 and 1, 1 are 2 points that both graphs have in common. So that's where those graphs would intersect each other. So this is just an example of how you can look at a table of values and get some information about those graphs without actually having the graphs.